A convex lens of focal length 20 cm and a concave lens of focal length 10 cm are placed 10 cm apart with their principal axis coinciding. A beam of light traveling parallel to the principal axis and having a beam diameter 5 mm is incident on the combination. Show that the emergent beam is parallel to the incident one, and secondly, find the beam diameter of the emergent beam. So first of all, let's draw the diagram. I do have a convex lens and a concave lens. The common principal axis, right? Now the focal length of, let's say, f1, that is of convex lens, is given as 20 cm, and the focal length of the concave lens, let us say this is f2, is given as 10 cm, and they are placed 10 cm apart. Fine. Now what is happening is that the beam of light is traveling parallel to the principal axis. Alright, so clearly if it is traveling parallel to the principal axis, it will be concentrated at its focus. Its focus will be at 20 cm from optical center, let us say at this point, B point. So the rays will be converged to the point B. Alright, so I do have that 1 by V minus 1 by U is equal to 1 by F. That is, let's say, for convex lens. Right, if I substitute the value, that is, the object is kept at infinity and the focal length is 20, so object comes out to be at 20 cm. That is where it is converging. Alright, now what is happening is that, of course, that the focal length of the concave lens is also at 10 cm. So if I apply the same lens formula for concave lens, then the object is kept at a 10 cm to the right hand side of the mirror, so it will be 1 by 10 is equals to the focal length. Now the focal length will also be negative because it is a concave lens, so it will be minus of 1 by 10. So both of them are cancelled. The value of V comes out to be infinity. So if V is infinity, then the rays will be diverged like this. Alright, now these are again parallel to the incident beam. So the first part is clearly proved that the emergent beam is parallel to the incident one, right, and that is parallel to the principal axis. In the second part, I have to calculate the beam diameter of the emergent beam. Alright, now first thing is first, that the beam diameter of the incident ray, that is this complete part, let it be PQ. So the length of PQ is given to me as 5 mm. Alright, and I do have to calculate this, let it be R and S. Let this point be O, let this be O dash. So in triangle POB and triangle RO dash B, I can write PO by OB is equals to RO dash to that of O dash B. Now the value of PO is known to me, that is 5 by 2, because it is half of the diameter, that is the radius, and the value of OB is given to me as 20. The value of RO dash, that is what I have to calculate, and O dash B is given as 10. So on solving this, I get the value of RO dash as 2.5 by 2. So the total length, that is the diametral pitch, the diametral of the emergent beam, is given as 2 times of RO dash, that is equals to RS, and that is equals to 2.5 by 2 into 2 is equals to 2.5.